Today we are going to learn about how do we merge the two sorted linked list given to us into a single linked list, and we need to return the head of that ultimate linked list formed from merging the two linked list over here. Fine, yes. So we have the two linked list over here, L1 and L2. L1 is storing the address of this first node and L2 is storing the address of this first node. I want you to keep one point in mind, that is L1 would always represent the node that has less value. Fine, yeah, getting that, yes. And over here, when we merge these two linked list, we would get this linked list when we merge those two linked list, and we would actually we have to actually return the head, so res would be returned. I also want you to keep in mind that we are going to create a temp node that would actually point to null. And why do I create this temp? This I would create because if I want to break some of the links, I am going to use the variable temp. Now let us try applying this one. See, initially what we do is we store L1 into that of res, because resultant would contain this node, because 2 is the smallest. Yes or no? Yeah, it would contain this node, so L1 would always point to the smaller value. Yes or no? Yeah, that's why we put in that of res. And also L1 is stored into that of the variable that I had told, that is temp, that is actually pointing to null. Fine, yeah. Even L1 is stored into temp variable. Fine, yes. Now let's begin the main part. Check whether L1's value is less than equals to L2's value. Yes or no? Yes. What do? We store L1 to that of temp and then increment L1. Fine, yes. Now again check whether L1's value is less than that of L2's value. L1's value less than equals to that of L2's value. Yes, isn't it? Yes. What we do? We store L1's value into that of temp and then we increment L1. Yes or no? Yes. Now check whether L1's value is less than equals to L2's value. No. False. Yes or no? No. L1's value is not less than equals to that of L2's value. In this case, what do we do now? In this case, we actually break this link. And how do I break that link? Temp dot next, and I would put in here L2, the address of this node. Getting that? So the link between this node and this node is generated. Yes or no? Yes or no? Yes. Now this link is broken. Did you get this? How did I do it? This was the link over here. Now in temp.next, I'm going to store L2. So this link has been created and this link is broken. Yes or no? Yes. Now in our linked list, what do we have? 2, 3, 4, 7, 9, isn't it? Yes or no? Yes. In that way we have now. Now the node point, what I have told you earlier, the node point, L1 should point always to the smaller element. Yes or no? Yes. Smaller element in the sense, what I mean to say is, now what we do is L2 is storing, L2 is containing the address of this node. Yes or no? Yes. L1 is containing the address of this node, yes or no? Yes. Now we swap them. We swap them. So L2 is pointing to this node and L1 is pointing to this node now. Yes or no? Yes. Now the temp becomes null now. Fine. Yes or no? Yes. Now let's go for further iteration. Now check L1 is less than equals to L2. Yes. When you say yes, I'm going to store the address of that of L1 to that of temp. Fine. Yes or no? Yes. And increment L1. Okay. Yes. Now check whether L1 is less than equals to L2. No. I say it no. Getting that? 7 is not less than equals to 5. Isn't it? Yes or no? Yes. So what is work of temp? Temp is going to break this bond. How it is going to break this bond? Temp dot next, it is going to store L2. Yes or no? Yes. Don't mind that I want to erase this one. Fine. Yeah. So now this bond has been created. This link has been created now. Yes or no? Yeah. How cool it is, isn't it? Yes. Now what we should do now? We should swap L2 with L1. So L1 would be over here and L2 would be over here. Yes or no? Yes. Now again check whether L1's value less than that of L2's value. Yes. Then store it in that of temp. Increment L1. Now check whether L1 is less than equals to L2. No. No. Isn't it? Yes or no? Yes. So what temp will do? What temp will do? Temp will break the bond. So it will break this bond. It will break this bond. Isn't it? Yes or no? Yes. It will break this bond. How it will break this bond? Temp dot next is equals to L2. It will create this bond. So this bond has been created. Getting that? Yes or no? Yes. Now what do we do? We swap L2 with L1. Yes or no? Yeah. So L1 over here and L2 over here. Getting that? Yes. Now check whether, now again temp will become null. Fine. Yes. Now check whether L1's value is less than equals to L2's value. Yes. Yes. Then store it in that of temp and increment L1. Now check over here, is L1's value less than equals to L2? Yes. Yes. Then what do we do? Store it in the temp node point. Okay, store it in the temp. Fine. Yes. And increment L1. Now L1 is pointing to null. Here we come to termination. Fine. Yes. And what do you do? What do we do? Now we need to join this one. And how do we join this one? In here, temp dot next equals to L2. Fine. Yes. So this bond will be created. So in this way we have actually merged the sorted linked list, isn't it? Yeah, we actually merged them. Yes or no? Yes. So resultant would be 2, then 3, then 4, then 5, then 7, then 9, then 12. Fine, yes or no? Yes. So we're going to return res. That's the approach. Fine, yes. I want you to just note this pseudo code. That would be very essential. That would be very easy for you to understand this thing. Okay, fine. Yeah, I want you to note this term down. Now let us see the code. So code is over here. First thing that I would check is okay, see, in code the first thing that I would check is if list 1 is equals to null, then I would return list 2, because that would be the list that will be sorted as on. Yeah, and if it's list 2 is null, then list 1 would be our sorted merge list as on. Yes. There could be condition that list 1's value might be greater than list 2 values. That means there could be condition that L1 might point to that of greater element first, and L2 port point to that of small element. So that we need to change. So we swap. Fine. Yes. Further, what do? We take the L1 and we actually store it into that of resultant. So that would be easy for us to track the merge list and return the res, the resultant list. Fine. Yes. And we're going to use the while loop, and in that we'll check whether the L1 L2 are null or not. They are not null, go further. Temp, as I told, it would always be pointing to null. We go in this while loop and we check out whether the first linked list, is it pointing to null? No, it's not. And is its value less than equals to L2? Yes or no? If yes, go in L1 would be pointed with that of temp, then L1 would be incremented. Again, it will be checked. If the condition becomes false, then the temp.next would contain L2. Quite in this way we have joined it. Yes or no? Yeah, I want you to just repeat the video. That would give you the answer. Fine. Yeah. And L1, as I told, always it should be pointing to the lesser value as compared to L2. So we would again swap. Fine. Yeah, and then return the resultant. And this is the solution, and I would just submit it. Yeah, all of this is accepted. Fine. Thank you. Like, share and subscribe.